Yes, I am back. Are we ready to go?
Yeah, I think we can proceed.
Okay. Just give me a second. All right, guys. So we've now seen basically how we can iterate through these different variables, right? Now, these commands that I'm giving you all here, they not just falling out the sky. I actually use the documentation link that I sent to you guys. And that basically gives you all of the various things that you can use when you're using Pumpkin PY, right? So let me quickly go back there and I'll show you some of them. Some browsers. Right, so if you look here, you can even iterate through the get compounds, where you can get, say, glucose in this case, and then print out its compound ID or isomeric smiles. The way we did it is slightly different. Instead of now looping to get compounds, I just got all the information at once using a variable, right? So there's different ways to actually access information and access compounds. So if you click on the compound link, you'll see here, you can access a compound from its compound ID using a specific number. Right, so that's all fine and great. Now, let's move on. So we've got the formula. That's what we're currently printing. But we can also print out other information. So let's try and see what else can we get. We can print out, because we're now iterating over compound, there's different things inside compound that can be printed. So let's look at the molecular weight. Right? We've done that previously already. And then we're going to also print out the isomeric smiles. If you want additional information on these things, you can also then check out that Pumpkin PY documentation for what else you can get. Right? And then the UPAC name. So I'm just going to do these for now. Let's quickly run this again. Now, obviously, we can see these properties being printed out for everything, for all of the compounds, for methanol, ethanol, butanol, hexanol, and the last one being heptanol, right? So if you look at the last in the list, you'll see we have heptanol, and that's its smiles, its molecular weights, and the molecular formula, and then hexanol, and so on and so forth, till we get back to the top, which is methanol, right? So that's all, that's fine. But now, what if we want this information somewhere else? And we want to write this information out, right? So say you want to write this information out to a file because you want to save it in a CSV file or something that you can then access later on. Now, of course, you'll have done pandas already. So the best would be to write all this out into a data frame and then write it out into a file, right? So let's quickly see how will we be able to take this info and now put it somewhere where we can then write it out into a data frame. So one of the options is, of course, you might have your own way of doing this. That's totally fine. Everybody programs differently, right? So there's no one solution. You decide on whether you want to use my approach or you want to use your own approach. That's totally fine. So what I'd like to do is I like to create, say, empty list for formula, weight, smiles, and UPAC, right? So these are all empty now. Now what I'd like to do is I'd like to fill each one of these entries with the relevant information. So a small task for you now. We're going to give you another maybe 10 minutes. I would like you to take the information that's currently being printed out here and store it in each one of these. So put the formula into the formula, the weight into the weight, stars into the stars, and UPAC into the UPAC, right? So that at the end of this, I would like to see each one of these things having the information for the formula for methanol, formula for ethanol, butanol, and so on in a list of items. So if I print out this formula, I want to see all of it. If I print out just weight, I want to see all of it, right? So we all get that? Give it a shot. I'm gonna give you like maybe 10 minutes at most. I'm going to quickly mute, but I will consider just give it a shot and try it out, and you can put any messages on Slack or also responding. Also, guys, if you have something, you're welcome to put it in Slack. Then we'll also try it out and see. So remember this right now, we're not even working off. I've already given you the PubChem commands that you do. Molecular formula, weighting, whatever else. All I'm asking you to do now is just store them into those things that are put up there, right? So those empty lists that are created.
Hey, Krishna. Hello, Krishna.
Yes.
I think you are having problems with the network. I don't know if maybe it's from my side only.
No, okay, I will quickly switch network also while I'm waiting for the guys to now do the task.
Okay, thank you.
All right. So, do we have anything, guys? I don't see anything on Slack. I don't know. Missing something. All right, am I audible on that side? Just to check.
Hi, Krishna. Yes, I can hear you now.
All right, great. Fine. Okay, so everyone, including you, did you try? I see lots of conversations, lots of talking in my venue anyways. I'm sure the same is happening that side everywhere else. But did you make an attempt? What have we done? And can I maybe get some suggestions in Slack or in class? How would we do what I asked? How would we take the stuff that's currently being printed to the screen and put it in each one of these things at once? So any ideas? Oh, apologies, my Slack is off. 1 minute, I want to just quickly connect back. Okay. Right, so I think I'm back 1 minute Slack. Right, so do we have any ideas, guys? I see some people have put some stuff. Okay. All right, one is saying plus equals PCB get. Okay, did you print it out to check that you got the right information? For me, it's tricky as data is in the library. Okay, I get errors, right? Fine, understandable. That's not a problem. Errors is part of learning, right? So the thing is, remember, these functions that we're using right now, this PCP.get compounds is getting all of the information, right? That's why it takes so long when we run this program. It actually gets all of the molecular information for that particular compound. So for methanol, it doesn't just get you the stuff I'm printing here. It gets you a whole bunch of other things as well. But we want specifically just these things, which we want to store so that we can write it out later. So what would be an option? We can try and see what can we do. We need to take these molecules and try and write out. So let's start with the first one. Right? So I've got an empty list. I call it formula. Now currently I'm printing this thing to the screen. Now one way to add things to a list is you just need to give the list's name. So you call it formula. So we call it up formula. And I just append to the list. Right? So basically now what I'm going to do is it's going to take empty formula and it's going to add things for methanol, for ethanol, butanol, and so on. And it's just going to add it up so that it all adds up together. Now let's quickly go. Before we do the rest, we want to see what this looks like. So let's just put them all in. Fine. I'm going to just add them all. So here I'm going to put weight dot append. Right? Then spouse dot append. And UPEG dot append. Oh, thanks, Benjamin. So if you wish to run this with Jupyter Lab, you can do so. Apparently. So right. So guys, there. If you want to use Jupyter Lab, apparently you can do so. So you can give it a shot there if you're having problems with the installation. Now, how do I see what's in each of these things? We need to print them, right? Let's just quickly check. We need to make sure. Because of course, we can go to the variable tab or variable explorer and see. But let's print it to screen because we want to be fancy. That's why I'm going to just print formula. Now, what do we expect to find in formula? If I print out formula, what do I expect to find? And also notice that I'm printing the thing outside my loop. Remember, I don't have any spacing or anything here, right? Which means if I put it like this, it's printing outside the loop. Now we saw when we printed the stuff inside the loop, it did each one by one. What's going to happen here if I print this thing outside the loop? Any suggestion? People on this Slack? What do you think? If I print something outside the loop, what do I expect to find? Keeping in mind that this thing has now been added to a list. I get print empty list from somebody on Slack. Okay. We will see when we run it, but it's not going to be empty. That much I can tell you. Anybody else? Want to take a guess? The full list. Okay, Grant, fine. You say the full list. That's fine. Because basically, what's happening is we were pending at each iteration, right? So there's 1, 2, 3, 4, 5 molecules. So all 5 of them should get added to this list one by one inside the loop. The moment we get outside the for loop, it should give us everything. So all 5 molecular formulas should be printed out at the end. Let's quickly check. Right, so we're going to run this. And I only have the one print statement, so I should only see one list of items. Right, there we go. One list of molecular formulas. One. Right, everything is in a single list, but we can access each one of them individually. So if I were to say formula in bracket 0, it would give me only the first element. 1, 2, 3, 4. 0, 1, 2, 3, 4. Right? 1, 1, 1, 1. So now we've taken the loop and we basically put everything into one. Doesn't this look familiar? You all did this right at the beginning of last week. Because when you're ready in a CSV file, you're ready in as a whole list of items, right? Which you use the data frame. So basically now we're trying to reverse engineer this process. We have lists that we've created. We now want to write it out into a file. We want to make a CSV from all of this stuff. So because there was an emphasis on pandas last week, we're going to make use of pandas again. Right, to try and take all of this information and write it out into a file. So what I'm going to do is I'm quickly going to import my pandas first, right, on the top here. And of course, if you were to write out, if you were to print out weights, smiles, and IUPAC, the same thing would apply. You'd get the list of all of the weights, the list of all the smiles, and the list of all the IUPAC names, one below each other, so that they're all nicely now arranged, right? So let's quickly import our pandas. I usually like to do my importing on the top, just convention, but you're welcome to import here at the bottom if you want to. Import pandas as PD. Zoom in a bit more. Right. Now, instead of the print statement, I'm going to create a data frame. We're going to do pandas.data frame. I'm going to create an empty data frame. Nothing inside, blank. Now the task. So we didn't do the CID. Let's quickly add this compound ID as well. I forgot to add the compound IDs. Well, actually, we'll get there. We'll do it in the next part. That's fine. We just don't do it now. Right, let's keep that. The compound, I want the formula. Wait. Actually, this is all. formula weight, the smell, and the IUPAC. Right. I would like you another job now to take the information that we've got above, right? This is result basically, but I want you to call it compound. So I want you to take the results that we've gotten above, all of these different lists that we created, and I want you to add it into this data frame called DF. That when I go print DF, I want to see the compound, the formula, the weight, the smiles, and the IUPAC, all in one data frame, where I will have then a list where it says the headings are compound, formula, weight, smiles, IUPAC. Below that will be then methanol, then ethanol, and so on. So when I say print DF, I want to see this list look like that in that form, but for each and every one of those molecules. Right, so the first thing you need to do is try and get this information into the data frame in the correct order, right? And in this case, basically the compound, you can just say this is the same as the result we've used so far, right? But the heading must be compound. So let me quickly put this on it. I'm going to give you guys another 5 or so minutes. And if you're having any errors, please put it in Slack, but then just make sure you give me a bit more information than just the error, because I need to know where exactly you're getting the error. And in your case, Eunice, that I have no idea. Bad request, that's internet issues, you know. Right, I'm going to be muting myself. I'm going to give you all an opportunity. Try and see if you can get it done. Okay, so I see there are some, or there's one that's got something to add it to the data frame. Yeah, one could probably do that. Let's try and see. I will try myself. Okay, let me see, right? Let's try and see what happens. I'm going to try and use Grant's suggestion and see what we get. Right, so you put it, you ask for compound. You need to give a heading, right? Followed by then the name. The name of the variable that stores this thing was result. Right? So then the next would be for formula. And then the name of the variable that stores the formula was formula. Ooh, okay, I need to shrink my screen a bit here so you can see. But the next was weight. And then smiles. And the last one was IUPAC. There we go. Okay, you don't need to see that side just yet. So basically, it's just the column name followed by the actual now list that's going to be added to that column is same for the formula, the weight, the smiles, and the unit, right? So let's print DF and see what it gives us. So let's print our data frame. Right, so there we go. If we look, there's our data frame. But for me, this doesn't look right. Does it look right? It's fine. You've got your compound, and then you've got the list of items that goes on the compound, formula. Okay, let's see. We're going to work with this and try and see what we get out. So now, let's say we wish to write this out, this information out to a file. Well, I want to write this information out to a file, which I'm going to call pubchemdata.csv, right? So we've done this part. Okay, so that's the one approach. That's basically if you wish to write all this information out, that's one way to do it, right? There is another way, which is a slightly longer way, where you then write each piece individually to the data frame. So let me show you that as well quickly. Where if you say, okay, compound is essentially then equal to result. You can do then df for the formula. See, it's the same thing, but just now, as opposed to putting everything in one long line, you're now making it separate. Whichever one works for you. It's up to you guys. Either one is about the same thing. The other way is actually a bit more efficient, I would think. But I'm going to just add these this way as well, just so you can see. Right. I'm going to get to your people's errors now. Just let me quickly finish type this out. Right. So if I take this out, I'm going to just comment that piece out. Delete those comments. Right, let's see what prints out now. See, so can you see the difference? The difference here is the way things are printed out, right? That's the main thing. Here, if I add the data frames column-wise, like I'm doing here, column by column, then when I print out the information, it gets printed out column-wise. So for printing purposes, I'm just going for this option, but you're welcome to do the other way as well. Right, so this is the way I'm going to do it. As I say, it's your choice. When you write out that CSV file at the end, as long as you have a comma separated list, that's all you need. Right, so let me quickly check some errors here. I'm getting an error when I import pubchem py. Ooh, really? Okay, check. Let me see. Okay, so fine. Mohammed, you're also fine. The pubchem py as PCP, if you're getting an error, but you're not, I don't see an error. You maybe didn't install the pandas because I see the error that you see here is something about pandas. So please make sure you've actually installed pandas in the environment. And then there's the last person. I keep getting the error. Maybe you can show us what the error is so I can see. Right, guys. So now we've got this thing nicely column-wise. And can you see? Very nicely, IUPAC names and everything else. Now I want to write all of this data. And also you'll notice, see, it's pretty cool. The smiles have a pattern, right? It's just adding an extra carbon each time. Because they're all alcohols, but all that happens is there's an extra carbon each time. So now, if you wish to now take this and write it into a CSV, that is something that should be able to do for me. Yeah, can't be memory loss in a week. It's been less than a week, actually. If you look at all the pandas that have been used throughout this course, people have done it many times. So how then do you write this information out to a file? And I want you to write it out. So you quickly. The pubchem data, right? So that's what it is. Pubchem data.csv. Okay, so I'll give you another 5 minutes here to just write this information out into a file called pubchem data.csv. I'll give you 8 minutes, then it'll be exactly 12. Those of you that are getting that bad request error, please check your internet connection because sometimes that might be the issue. Alternatively, you need to make sure that the ticks, especially if it's a Python code, that you're actually using the same code. So sometimes you use a single quote and a double quote, that might also give you an error. You mustn't mix up the quotations. Make sure you keep it consistent. See, like here, it's all single, so don't mix them up. Oh, guys, while you're still busy with that, just quickly, I need to add something here because we're going to need to use the CID at some point for something. So let me just add it here. So this is just the compound IDs of the molecules. So we do PCP.get CIDs. Right, so please just add this PCP. So basically we just make a CID list and then we append the compound IDs to the list. And then, of course, you still need to write out that other information into CSV file. What we can also do is just include it in the CSV, right? So here. Right, give me a few more minutes to give me that CSV file. Okay, I see some indication on the chat here. There's some commands people are putting in to CSV. Okay. Right, so and Mohammed, just make sure you add the CID as well. So that's another one of those columns you must add in. All right, okay. Everybody seems to be on the right path. So let's quickly have a look at this, right? So we're gonna do a df dot to CSV. For this pubchem data.csv. going to use a separator of commas. By default, it is commas, but I like to put it in anyways. And then index equals false. The reason why I don't want the indexing is I only want this part here. I only want everything from column, formula, and weight. So I only want these things here to be printed. Right now, I don't want these indexes to be printed in the CSV file, just for convenience, basically. Right, so I'm going to run this. Right, so it is run. Now let's quickly have a look. I need to find my folder where I saved everything. Right, and there we have a CSV file. And guys, I can't fight over you all and the noises. See, it's not easy. I'm doing online, so please can we now keep it down. Right, so if you have a look, here you go. Right, so now we've got everything in a CSV format, which is convenient for you. And here at the end, I've added those compound IDs as well. So that just makes it so that you at least have everything in one place. So now when you're working with large data sets, you can often then just write all of this information into the CSV, which makes it then easier for you to go through the data after. Right? There's also ways to even write things out in tabular form so that you can put the table in a paper or wherever you want to. Right, so let's quickly close this. Okay. So far, all we've done is we've read in information, we've downloaded the properties of these molecules. But nowhere have we actually downloaded the molecules themselves, right? So if you consider everything we've written up to this point, the molecules haven't been downloaded to our machine. We don't have proof that they exist. We know they're there. We know they have these formulas and whatever, but we don't know what they look like. So now we need to try to figure out how do we actually download the molecules themselves. And typically in chemistry or in PubChem context, most of the molecules are written out in what's called SDF format. I don't know, structured data file or something along those lines. But basically, if we want to download those SDF, there is actually a way to do it in this Python script, which will allow us to download the molecules. This then makes it convenient for you. If you have, say, 1,000 different molecules that you want to download, you don't have to go one by one to PubChem and download each one. You just give it the list of compounds and you just download them all at once, right? So that's our next objective. We're going to try and see how can we then download these different molecules from PubChem. Right, so at this point, what I want you all to see is that, can you see, all I've done so far is I've built this script up. We started from nothing. And now we've gotten to a point where we actually can print out the properties of 7 different molecules, right? So the whole objective is you should always do things in pieces. And when you get it working for a small set of data, then you apply it to the bigger set of data. Don't ever try and go big immediately, because what's going to happen is it's going to take forever to read information in before you get an error. Now imagine waiting 10 minutes only to find out, whoops, the error was somewhere. So it's always better to work with small data, fix all the errors, and when everything's fixed, then you run it on the bigger picture. So that's how you should work, right? With any programming or whatever you do. Always make sure you do smaller data first and then apply it to the bigger ones after. Right, so I'm going to quickly show you something when it comes to data frames, right? So you can iterate through data frames as well. Like you iterate through these lists that we have, there's a way to actually iterate through the data frames row by row. So because pandas and PubChem PY don't play nice with each other, we have to actually do it iteratively in order for it to download molecules one by one. So if we quickly now have a look, this is how you would do an iteration in a data frame, right? So we say for index and rows in the data frame dot iter rows. Right, and here I'm just going to print the rows to show you what it looks like. And what I'm also going to do is I'm going to print rows of just the CID. Because remember, it's still a data frame. So when we access things in the data frame, we still can access it based on its column name. So we've got a column name called CID. Here. So all I'm doing is going row by row, but only for that column in the next one, right? So let's quickly run this and see what do we get. Oh, I will show the CID formula now. Sorry, Grant, I didn't see that. Only saw your thing now. So can you see if I print? Oh, okay. This is not giving me much. Let's quickly do it this way. I'm going to say print each. Right, I'll run this quickly and then I'll quickly go up to show you guys that CID command again. Right, so there we go. If we go up here, we'll see. So literally, it just prints each row and then it prints out everything, right? And here is only the CID. So for each row, it will print out the compound, the formula, the weight, the small, the UPEC, and the CID. But this command here only prints out just that. So can you see that? We've got the whole row versus only the ID. Right, so now, oh, before I forget, let me quickly go back. Right, so there's the component ID one. If you missed it, basically I just made an empty list and then I get component ID from Pumpkin. In the first four, yeah, that's the one. That's the one you're talking about. Okay, great. I see other people typing frantically. No, I'll get the whole finished product at the end of this, but you'll need to understand the steps we used to actually get. Because if you need to edit this thing one day, you need to know where to edit it and not just go randomly edit something and base it up. Right, so as I say now, if we want to print out each row, right? So we've got the full row with all the info versus just the ID. So keeping this in mind, I'm not going to take this print statement, but I'm going to leave you up with that. There is a command called pcp.download. I'm actually going to make it a comment. pcp.download. Right? So this is in PubChem PY. You can either check the documentation or you can type it out in Spider and open the bracket to see what the different things are needed by pcp.download to download a file from PubChem. The next task I've got for you is I would like you to download those molecules from PubChem in SDF form using that command. It's a one-line command. You're going to put it here. I'm giving you exactly the position where it needs to go. But there's something that must go in the brackets for PCP download to work. So either check out the documentation on that link that I showed you, or open the bracket in Spider and see what does pcp.download require in order for you to download it. What is the difference between the versus default is comma separated list, right? So if you say SEP, it's basically comma separated list. Whether you put SEP or not, it's still going to be a comma separated list. I just put it in because I like to put in the separator. But you don't have to include this part. If you just put this without that and you just use the index, that will still be the same thing. You'll get the same file out. Okay, I give you until 5:15. So about 6 minutes actually. Or therefore, it's data frame, data with a capital D, frame with a capital F. Yeah, you got frame with a small f there. It must be capital F. Because look, where's my DS now? There, it's data frame, capital D, capital F. Okay, Nintendo, there's your CID command here. Yeah, you'll know what needs to happen. It's pcp.download, so you can do that last. I'll keep that up so other people can also get that one. Because I see a couple of you didn't get that. It's fine. I'll leave this up for a while. Okay, guys, so first that it so fine. Just making sure I'm in the right folder here. Right. Let's go down. Let us have a look. How do we use TCP.download? I'm going to delete this line here because I don't need it. Right, now it tells you a bunch of stuff when you open the brackets. It says out format, path, identifier, namespace equals CID, domain equals compound. There's a whole bunch of stuff here, right? So the first thing it needs is, what format do I want to download? Now I told you I want an SDF, right? So we have to tell it. SDF, that's what I want. I want you to bring me an SDF. That's what I want to see in my folder when I run it. But then the next part is, okay, look, it asks you for the path. So where do you want this thing to be downloaded is what it's asking. So in Linux, which typically a lot of the stuff that they do for, because this is more bio sort of informatics slash chemistry, right? Computational chem. They often like to work in Linux. So remember the command prompt that they showed you last week? This thing is based off of that. So the path, you need to give it like a Linux-based path. So say we want to download it here to where you're currently working. So where your Python script is, you need to tell it, I want it here with a dot. So dot slash means bring me the file to where I currently am. If you want it anywhere else, then you'd say slash C users, the whole story, right? So we don't want that. We want it here. Oh, also, it needs to be in ticks. Sorry. Now, what do I want to call this thing? Because remember, this is now iteratively doing the stuff, right? So if I give this file a specific name, so say I name this thing test. Let's do that. Let's do that. Let's do it. We'll say, okay, I'm going to call this thing test.stf. Right, like this. So I'm saying, bring me that file from wherever, bring me an STF file, and save it as test.stf in my current location. That's what I want you to do, right? And then we have to put a little bit more information. We have to tell it, okay, what does it need to use? It needs to use the compound IDs when bringing me the molecule. So that's what the identifier is. What am I using on PubChem in to identify this molecule? I want to use the compound ID. So I'm going to use each compound ID, right? Because there's more than one molecule in here. There's not just the one. And then the last thing that we need to tell it is, what are we downloading? The namespace. It's already there. We're telling it here, we're giving it a number. When it goes to PubChem, PubChem needs to know, what does this number mean? The number means CID. Right? So it goes, looks for a SDF, it stops there at PubChem and says, look, I've got this number. I'm looking for this number. Then PubChem needs to know, okay, what is this number? Then it tells PubChem, yes, that this number is the CID. So PubChem then says, okay, here's the molecule with the matching CID. Here's your SDF. Take it. Right, so let's run this. Now, of course, it's going to run, it's going to finish because I don't have any print statements anymore. So when this thing's done, oh, something's wrong. So apparently this already exists. What is the problem? Oh, does test.stf already exist? I don't have a test. Let me try and see. There's a mistake. Oh, if it does already, I don't think I had a test. Let me quickly check. Oh, it's there now. Fine. I know why there's an error. No problem. Right, so we've got this here. Great. But if we quickly go to the folder where you have your Python script, right? There's my folder. I'm opening this up. Can you see? There's a test.html. It's already here. So I downloaded something. What is this something? I don't know, maybe we can open this with Notepad to just check. Right, so it's 887. That's the compound ID. That's what got downloaded. But now why is it giving me an error? It's a problem. Why am I seeing this error there? It downloaded something. So what's the problem? Anybody? Even online? Eh? No, everyone. So anyone that maybe thinks they know what might be causing the problem, you can just pop it in the chat. Is it trying to prevent an override? It is, of course, we can see that, right? It says you need to add in the keyword override equals true. But what is it overriding? Didn't I just ask for chess.sdf? I asked to bring me one file. That's what's supposed to be there, isn't it? One file. But when we're working with one molecule, from the beginning of this thing, after I've done all of this stuff, right, to print me out the information, put it into a data frame. If you go look at your data frame, don't know whether mine gives errors. Yeah, mine has an issue. It's fine. But if you look at your data frame, does your data frame contain only one thing in it? Let's quickly go back here. Your hint is up here. Is there only one molecule? There's not, right? Exactly. So, you're right. It's iterative. Because quickly, let's go back down here. We are going row by row. All that's happening right now is it's downloading the first molecule. And when it gets to the second, it hits an error. Because we are asking it to put everything into one file. That's not what we want. We don't want all these molecules to be dumped into one single file because then they won't be recognized as different molecules. We want them as separate files, right? The easiest would be to separate the files. So in this case, it does the first file, and because override is not on, it doesn't do the second file. That's fine. We could have added the option, override equals true. Let's do that. I'm going to quickly do this to show you guys what happens, right? Remember the number was 887, right? 887. So let's quickly see what happens if I add an override equals true. And I'll run this again. Right, this is a trial and error process, as you can see, trying to figure out what's happening. Right now, there's still an issue. So what is the issue? The override true clearly is not supposed to be that way. So we're supposed to write it out some other way. Where is my formatting? Oh, I'm not supposed to have it in ticks. That's probably why. All right, let's do it again. So again, as I said, keep in mind 887 was what we had before. I want to see what happens now if we run it again. Aha, no errors. Great. Working, right? Must be. Let's quickly go back to our folder. Let's open this test file now. That's 8129. Where's 887? It disappeared. So what's happening? So yeah, it's 8129. It's a problem. It's not the same molecule anymore. So basically what's going on here is if you do decide to override the molecules, it goes into the first one, which was methanol. It then switches to ethanol, overrides methanol, switches to butanol, overrides ethanol, and so on till it gets to the end where the last molecule we have was heptanol. So that molecule in that SDF is heptanol. Where's the rest? Nothing's there. But we asked it to download all. It did do it. It just didn't bring everything to us. It overrode the file every single time. So you need to be careful when writing these files out. You don't want to write it out with the same name. You need to have different names for the different molecules. Right? So this is how you do it. Actually, maybe actually. No, okay, fair. Time-wise. So here, instead of telling it we want test, I'm going to say write out to the current location, but I'm going to now add on something, right? I'm going to say, okay, so the file that I want is going to be called, it's going to be a string, and you're going to pull it from the compound IDs. Right? So basically what this does is, it says, okay, I want to download an SDF. I want you to download it here, but I want the file name to be a string of characters that comes from the compound ID. So that number of the compound ID, I want you to have that number .sdf for my file. So 887 will be 887.sdf and so on. For all of the molecules, so I'll have 6 different molecules download in my directory. Right? And the rest of it stays the same. You can keep the override equals true. It's not going to make a difference now because we're going to have separate molecules being downloaded. So let's run this again and let's see what happens in our folder this time out. Right, so it's finished. Now let's go back to our folder. Can you see? 1, 2, 3, 4, 5. 5 different molecules. Ignore this because that was the red machine. Deleting it. There's all our SDFs. Okay, right? Now we're able to download these 6 molecules without actually having to go through the schlep of first looking for them on PubChem and downloading them one by one. Because usually on PubChem you can search and then it'll give you like similarities and whatever else it may be. But you can either download this molecule as it is, or you can download the similarities. You can't download separate entries unless you physically go look for each and every entry that you're looking for. So that's our SDFs. Now we're able to download all of them without going through the headache, right? And of course, if you change the molecule name, you can download other molecules. Right, now. Okay. 25 past 12. Right, great. Now we've done this for these things, where we actually now had to specify names piece by piece. I will keep this last part up because I'm sure a lot of people will still tab it. So let me zoom out a bit so you can see it. Right, there we go. There are 2 files that I've given you in Canvas. One is called molecule list.txt and the other one is called reduced list.txt. I would like you to download those 2 files, right, onto your machine. And basically, the only difference between those 2 files is molecule list has a list of 256 molecules. Reduced list is the same file, but with only 2 molecules. Because remember I said, when you're testing, always test with the smaller set first. So I would like for you to take a reduced list, read it into Python, and do the same thing, but on those entries that are given you in that list. So not much needs to change your code-wise. You need to just use the list and download first the 2 molecules that are there in that list. So just read the list in, do the same process here. Maybe there might be 1 or 2 things that you need to change, and then download those 2 molecules. Start with the reduced list. Just download those 2. Try and get me those 2 SDFs. Right? Those of you online, same. So I would like you to just download those 2 lists. Make sure you're using reduced list initially. And make sure you copy it into your folder, right? So let me quickly, I think I got mine in downloads. Yeah, so you download it, will be under downloads. Just take both the files, cut them out from your downloads, and then take them to your documents under the same folder where Python is. Right? So I would like you to now, instead of using these molecules I gave you here, I want you to read it from reduced list and then do the same process, where you write down a pubchem data.csv file for me. But this time it's going to have the two entries that we now put in the list, and it's going to download two molecules from the reduced list. So that is your task. I will give you like 10, 15 minutes even. Actually 10 minutes. And then I want to show you all the rest of the parts without you all physically doing it because your RD kit wasn't working. So right, so I'm reading Slack now. So if there's issues, you can just message me. No, so it's initially just the reduced list. So once you have reduced list working, then you can change reduced list to molecule list and do it for all. Reduced list only has two entries. The other one has like 256. So downloading those 256 can take some time. Yes, I want you to create the CSV and the SDFs. Just download the two initially. You can always try out the rest of them at the later stage. Oh, sorry. I scroll down. My apologies. Here we go. Oh, also, I forgot to add the lists contain nothing but compound IDs. So the list that I provided you with is not molecule names, it's just compound IDs. So keep that in mind when you now need to set things up, that it correlates to the compound IDs. We'll give you guys till quarter 2 because this is not a short task. Okay, so I'm gonna be kind and give you like the first part. At least how to read the file, that part will give you that one. So you'll be surprised, read CSV doesn't only need CSV files. You can actually use it on text files as well. So you're gonna just basically read the data in, and not molecule, sorry, it was reduced list. My bad. Reduced list. Right, and the names we really need is CIPs. So keep that in mind. Where's the computational chemistry? I'm going to show you what my final script looks like. And then let's hope and pray you'll finally see the computational chemistry component. Because remember, these are still only 2D structures. We can't do anything with them until they become 3D. So when I'm done showing you the solution for this task, I'm going to show you the final script that I wrote, which will then convert all of your molecules to 3 dimensions for you to then use in things like docking, etc. Yes, so you remember previously compound was the names. That comp that you have there is actually corresponded to the names and not the CIDs. So that's why comp dot molecular formula corresponds to actually a name dot molecular formula, not the CIDs. So you have to find a way to maneuver this thing around that you still get those things to iterate without using only the compound IDs. Okay, guys, so there was still a lot more that I wanted to do. But what I'm going to do is I'm going to show you all what the final product looks like, right? Because one thing I'm quickly going to show you is if we look at any of these SDFs, even the ones we've downloaded earlier, I'm going to just use an application that I have on my machine. You can even use an open source tool called Avogadro that will allow you to visualize molecules. I'm just going to use Gauss View for this purpose. But what you will notice is these SDFs that you download, they are two-dimensional structures. They're flat. So my molecule now, because the openings to come on. Doesn't want to behave. I can't see it. What is going on? Okay. Let me try and open manually. Okay. Nothing. I don't know where it is. Let's close this. And let me try the other application and control. Right, so I'm going to try and open one of those SDFs that we downloaded earlier. Okay, so you see, Avogadro recognizes that this is not a three-dimensional coordinate, right? So there. So can you see this molecule is flat? You cannot use this in computational chemistry because you require three-dimensional coordinates. Three-dimensional coordinates, even though this looks 3D, it's not. It's flat. It's very flat. Remember, when it comes to chemistry, the CH2s need to set at a certain angle and whatever. So this is not 3D. This is 2D. Right? So this is like drawing a line of carbons. That's basically all it is. So what's required from a lot of these packages is that you get a three-dimensional structure. So what I was going to show you guys, and what I will show you when I show you the final script of mine, is that you need to convert these things to 3D. So fine, there's software packages which you could use to do that. But sometimes you might need licenses for some of them or whatever it may be. Now there is a way in Python to actually do these conversions automatically on the fly. Right, yes, Gaussian and Avogadro open, Avogadro is open source, Gauss View is not, that is licensed. Right, so let me open my one that I was doing yesterday. Right, so I'm going to walk you through this. You don't need to type frantically. I'm going to upload this when I'm done. Right? So let's go through this. Now, of course, when you got your code running and you're happy with it, one thing you must always do is you must make sure people know it's yours. Right? So you label there and you say what it does. So in this case, this is a script that's used to run through a list of compound IDs and download the SDF entries, as well as write out the compound properties to a CSV file, right? So what I used here was PubChem P1. We did that already. We did pandas. I also import OS because I want to create folders. I want to make my thing a little bit fancy. I don't want everything to be in one place. I want separate directories for where the SDFs get written and where other information goes. So I know where it is, right? Now this RDKit, when it does work, you would then also import different things from RDKit. So there we go. We now do the reduced list, right? We read through it and we read through it as a CID. Same thing, all I did, fine. Some of my lists are differently named, but the same principle what we use now, all of that's the same, right, as what you guys have now. I didn't specify CID here because it's already stored. I'm reading it from the list. Why do I need to specify it again? It's already there. So it's in the data frame. I don't need to put the CID down again. That's why I deleted it. Now, as I said, I want to be fancy. So in order for me to be fancy, I first need to check, does there exist an SDF directory in my current folder? If it does, I say, look, the directory already exists. If it doesn't, I make myself an SDF directory. Right? I then iterate through my data frames, which has the CIDs, the compound IDs. Right? I get the compounds using those CIDs now, not the names. We're not using names anymore. We're using compound IDs. So you see that cell that you all had changes a little bit. It's not the same as the one I gave. Now again, when I run the script, the problem is I don't know what's happening in the back. Things are busy doing its thing. I don't know. So I decided, let me put a print statement so that people that run my stuff know I'm downloading molecule X. And when it goes to molecule Y, I know it's now downloading molecule Y. Right? I then download the molecules, but I put them into the SDF directory. Right? And I give them the compound IDs.SDF, fine, because I want them in separate files. I put override equals true, just in case the molecules were already downloaded, we'll let them override it. It's fine. Right, then I say download complete when it's finished. Right now I wanted to do an extra piece. So I've downloaded my SDFs, right? I'm happy with it. Molecules are all there. Everything's working. So the next thing is that part stays the same. Remember I told you I wanted all of this information in a CSV file. This doesn't change. It's still compound income because we got all the compounds from here, right? So that's got all the properties already stored in. So when we append, we just append the same thing. Nothing changes there. And again, data frames, we populate them exactly the same as we did before. Right. Then I write it out to a CSV file so that all those properties go somewhere. Now, going to be even fancier. Now I want to make pictures. So there was a comment in Slack there, where's the comment came? It's coming. So if this images folder exists, again, I say it exists, otherwise I make it, right? So what are these images? Basically, I want to make pictures of all of the 2D structures. Because remember, we download all of these molecules from PubChem. But when I have to put it in a paper or something, I usually have to go to ChemDraw to draw the structure, right? Using my script, you never have to use ChemDraw again. It will give you the 2D image for that molecule, just like ChemDraw would draw it for you. And I can put the 2D image with the hydrogens or without the hydrogens. It's up to you. Right? Then the last one, I want the 3D molecules because these are what I need to use for things like docking studies or whatever else it may be. So again, I check if that directory exists. Now let's try and create these different things. So we iterate through all our rows. We're now using RDKit, right? RDKit is just converting the molecules. It's reading in the smiles that we downloaded already. We've already obtained them, right? It's stored somewhere. So it reads the smiles from the data flow. It then draws me the molecule to produce the image, which is that structure, which is the 2D structure that you would get from chemical, right? I then save those two images, right? I add hydrogens because remember the molecules that get downloaded as SDF, typically, a lot of them don't have hydrogens included. So when you want to do CompChem with them, you have to usually add in the hydrogens, especially if it's smiles, right? There's no H's. So I add H's, I embed this molecule, and then I optimize it because I have to do some sort of minimization to get the structure into its optimum form before I can dock it. Right? I do a minimization, I then take all of that information and dump it into a file, which I call something.move. Not a lot of code, right? Let's see what it does. Hey, that's it. That's the end. Let's run it. Right? So I'm going to run this. So remember I said reduceless has only two molecules. So there, not even tells me, downloading whatever. See, it looks just like on Windows now. When Windows says progress bar, there you go. You got your own progress bar. So there, two molecules downloaded, images directory is already there, 3D directory is there. So let's quickly go to my folder where I did one of this stuff. So I'm going to go to test. Now, can you see there's an images folder? There's my SES. So if I open these, there'll be the 2D molecules. So again, I don't know, my thing didn't want to open. Try it again. Not working. We will try again with one of the other molecules. But what I want to show you is that's a 2D molecule. Then let's go to images. Pretty cool, right? There's the structure. Mesh. Right? There's the one. And then there's the second one. So there, your O's and everything. See? And these pictures don't look very clear right now, but there's ways to actually manipulate them to make them clear enough for you to put in a paper. And what you can also do is there's also some people that have written stuff that allow you to make it in blocks, where you can have a single image where it's all blocked and all of your molecules are just drawn in the blocks. Right, and then the final thing was then getting the 3D structures of these molecules. So there's the 3D. And again, I think this thing is now not behaving itself, so I can't see there. Let's quickly go to Avogadro and we'll open it here. Right, I'm going to show you what the difference is between that 2D one I showed you earlier versus what it's supposed to be when you use it in any computational chemistry tools. See the difference? That now is a 3D molecule. See? Was the structure not flat? And in real life, things are not flat. I mean, imagine, what would we look like? So that's it. Then this molecule you can then take and you can put it into other packages to do things like if you wish to do docking, or even if you wish to optimize this at a higher level using things like quantum mechanics. Sorry, guys, we got a bit of construction going on here in the background. But we've reached, I think we made good time. So what I'm going to do now is, as soon as we finish here, I'm going to upload this Python script because that's all you will need. You actually don't need anything else but this Python script and then those files that are already on Canvas. So I will put this script up now on Canvas, and then you can use it on molecule list and run it and see what it does. It should then give you all 256 molecules and the 3D structures for them. So yes, thank you very much for listening. I hope I didn't bore you.